Good day everyone, welcome to 4 Points Academy. So in today's video, we want to talk about another examples under the time complexity. How are we going to derive our time complexity? So this one they ask us sum of the elements in an array. Now assuming we have this array of 4, 2, 3, 5. Now asks us to sum everything together. And initially, the numbers of n for this array is the number of the number of array, which is the n for us is 4. That's 1, 2, 3, 4. But in an array, the array, we want to count array, we want to identify array, we want to pick out an array. Array is using what we call the index. So we have index of 0, 1, 2, 3. So if I want to call on 5 like this, I can easily call on 5 by using, let's assume this array is A, it's going to be A of 5. So you are calling A of 3. A of 3 is going to give me what? It's going to give me 5 like that. So now, we now have the algorithm of an array, that's algorithm of array sum A, that's the name of our array is A. N, the N is what? The numbers of array. Now, we now have one thing we call this, just like a start, we want to start. We said S, let our X equal to 0. Now, if S is equal to 0, for I to be equal to 1, that's for I to be of index 1 to N, that's to start from number 1 to number 4, that's from number 1 to number 4. Do, some certain is going to happen. X equal to X plus A of I. Now, the first element is 4. So for this one, what's going to perform here is going to be S equal to our X, initial X is what? 0 plus A of I. That's A of what? A of 1. Now the A of 1 is, if our this thing is 4, that means it's going to be 1, 2, 3, 4. So this one is going to be 1, 2, 3, 4. We're going to have what? It's going to be A of 1. And A of 1 is going to be what? It's going to be 4. Which means this array is not starting from what? It's not starting from 0, it's starting from what? It's starting from 1. So it's going to be 0 plus 1, that's going to be equal to what? It's going to be equal to 4. Now, what's going to happen here is going to return X. Our new X will now be what? Will now be 4. We don't want 0. Now, if new X is now 4, we go back to this. Instead of X to be 0, the X is now be what? It's now going to be 4. Now, if X is now 4, it continues like that. Store it, go back, store it, go back, store it, go back until what? Until we reach a final 4. Well, what's done our focus? Our focus is how are we going to determine the time complexity. Now, the time complexity like that, we determine the time of complexity from what they call the program step. Now, the program step we need to do here is we need to firstly focus on this. That's how many steps is this X is going to run. For every algorithm you are doing, it's going to just run only once. Just one. Now, for I to equal to 1 to N. Now, if you check it for I to equal to 1 to N, which means if you start it from 1, it's going to count it up to the number of the number of your elements. So the first element, the second element, the third element, the fourth element, this thing is going to run that time. So which means we are going to just say we have for this one is going to be n plus 1 because it's going to start from initial, that's the first bit. Then if you want to calculate, if you want to solve this thing, you need to go, that means you need to go 5 times before you can reach 5. If you want to go for 3, you need to go 4 times, that's 3 plus 1. You need to go 4 times before reaching this place. That's why we have n plus 1. Now for this one, how many times does it going to run? It's going to run only once. Because this one I say it's going to run only once is that it's taking the running time of this. So it's going to depend on the n of for loop. So this one is going to take n. Then this return is going to be 1. Because this one is going to return. But this one is depend on this. Because for this thing that we are doing, we are going to be execute. If this one is not taking place, this one will going to happen. That's for loop statement. Every condition inside this is going to cover up with this. If this one is executing 5 times, this one is executing 4 times. So then this one is going to just be only once. Now to now calculate the sum of elements, so the time taken, the time complexity now is very simple. Because I tell you, time complexity is the sum of what? The sum of all steps and programming steps. So we have 1 plus n plus 1 plus n plus 1. So 1 plus 1 plus 1, that's what? 3. So you have 3 plus n plus n, that's 2n. So now bring it in a normal way, it's going to be 2n plus what? Plus 3. So for this algorithm to run, it's going to be in form of what? 2n plus 3. Now let's check. Assuming your input, your n, that's your input is 2. It's going to be 2 times 2 plus 3. That's going to be 4 plus 3. That's going to be what? It's going to be 7. So the time is going to take for this thing to run, if you are dealing with n to the 2, it's going to be seconds. But that second is depending that you are using microseconds, gigaseconds, or normal seconds, which is seconds on its own. It's going to be from this 7 seconds. So this is another example on how to find the time complexity of a given algorithm. Thank you so much. Follow and like and subscribe.